So I'm going to start by presenting the APOD for February the 22nd. This is the picture. It's been named Moon Rising Between Starships. Now, this photograph was taken at Boca Chica in Texas, and it was taken by a 20-year-old spaceflight photographer named John Cross. You can see his name right over here. Now, this photograph really has two main parts. The first part are these two things right here. These two spaceships. They were built by a company named SpaceX. And SpaceX just last year became the first private company to send humans to the ISS. Now, what SpaceX has been working on recently is something called the Starship. The Starship, and that is what you see in the photograph. Now, Starship is supposed to be a two-stage, fully reusable spacecraft that can go from bringing cargo into orbit around the Earth, all the way to sending humans to the Moon, Mars, and beyond. But before we can do that, we need to test it. So what you see here, these two are actually the test spacecrafts. This one has been named SN10, and this one SN9. Now, the SN stands for serial number. That's the serial number of these spaceships. Now, a bit of a backstory. Before these two tests, there was another test done called SN8. And in that test, what was supposed to happen is that the rocket went straight into the sky, reached heights of about 10, 12 kilometers, and then it would maneuver and return to Earth in a horizontal manner. So it would be belly down, returning to Earth, and just as it's about to land, it would use thrusters to place it back vertical and touch down. With SN8, there was low pressure, and that caused the entire rocket to hit the ground too hard, causing it to explode. Something very similar happened with SN9. With SN9, one engine failed to fire, and the whole thing blew up. But now SpaceX, they think that they know what the issue is, and they said that they've fixed it on SN10, so we'll wait to see what happens with SN10. Now, the other part to this photograph is the moon here. Now, this moon, yes, it is a full moon. In other words, we can see the entire moon. The entire moon is fully illuminated. But at the same time, because of when this photograph was taken, which was in the month of January, it is not only called a full moon, but a wolf moon. Now, the reason that there is an actual name to the moon because it's in January is because you see moon cycles, a full moon cycle from new moon to full moon back to new moon takes about 29.5 days. And because of that, if you were to add up about 12 cycles, you get 354 days, just 11 days short of the full 365, which means that in general, every month there should be a full moon. Now, sometimes every 2 to 3 years, yes, there is a second full moon in that month. Those we call blue moons. But in this case, in this year, we only have a single full moon per each. In this case, the full moon of January has been named the wolf moon. And the reason it's called wolf moon is because it's commonly associated with the belief that the Native Americans called it wolf moon due to the howlings of the wolves during that period. And why were the wolves howling? They were hungry. This was in the month of January. So that's really what there is to this photograph. You've got SN10, SN9, and then you've got this beautiful wolf moon looking as if it's rising from between the two starships. Okay. Now, the second photograph that I will be discussing is of February 21st. And its name is NGC 2244, a star cluster in the Rosette Nebula. Now, let me go to this photograph. This photograph was taken by a man named Don Goldman. and he's also referred to as Astrodon. Now, you see what makes Astrodon very special is because he is the developer of Astrodon filters that are used in astrophotography. So the man behind these filters used on cameras is Don Goldman, Astrodon. So this photograph was taken, and although it's the APOD of February 21st, it was actually taken in January of 2014 at the Siding Spring Observatory in Coonabarabran, Australia. And now what this photograph depicts is something called NGC 2244. Now, 2244 is just its number. It's a 2244th, and something called the NGC. Now, the NGC is the New General Catalog for Nebulae and Star Clusters. So this is the 2244th in that catalog. Now, NGC 2244, also known as Caldwell 50, because it's part of the Caldwell catalog by Sir Patrick Moore. It is inside a nebula called the Rosette Nebula. Now, the Rosette Nebula, it's much bigger than this, and the Rosette Nebula is sometimes referred to as the skull. Now, it's partially visible from here. The reason it's called that is because this area right here that we're looking at, this is supposed to represent the left eye of the skull. This area towards this side is the right eye, and you can see some parts of the nose right here. But because this is more focused on NGC 2244, you can't exactly see the whole thing. Now, the Rosette Nebula is inside a constellation called Monoceros, the unicorn constellation, which is right in the center of Gemini, Hydra, Orion, and Canis Major. Now, NGC 2244, the brightest star in terms of apparent brightness. Now, in terms of apparent brightness, is a star called HD 46223, which we can see right here. This is HD 46223. Now, the HD, that stands for the Henry Draper catalog, which it is a part of. So now, as HD 46223, the star itself is about 38 times brighter than the sun, but in terms of its temperature on the surface, it's a little over 4 times hotter than the sun on its surface. Now, yes, I did say that HD 46223 is the brightest star in terms of apparent brightness, which means that it's not in terms of the actual brightness of the star itself. If we were to talk about its actual brightness, it would have to be this star right here. Its name is 12 Monocerotis. Monocerotis. This star is 155 times brighter than the sun. Now, at the same time, these two stars, they are different types of stars. 12 Monocerotis is called a K-type star, and HD 46223 is an O-type. Now, these classifications using K and O, they come from a classification called the. They come from a classification where the order of the letters, which goes O, B, A, F, G, K, M. In that order, M is usually referred to as the least as the coolest of all the stars, while the O's are the hottest. And as you could see just there with this O-type star, it was 4 times hotter than the sun. Now, the other stars that you can see here, a lot of them are O-type stars because NGC 2244 is largely populated by O-type stars, which emit mostly in the ultraviolet spectrum. Now, the other stars you can see include this one right here, HD 46150. Then you've got this one right. Wait, let me make sure I've got the right one. This is HD 46149. So this is 46149. This one right here, that is HD 46106. And this star right here, this is HD 46056. So all of these HD 46s, they are all they're all O-type stars. It's only this one right here, the 12 Monocerotis, that is a K-type. Now, at the same time, let me zoom out a little in this photograph. There are actually specific colors to each of the different elements. Sulfur, you can see as the parts shaded red. Hydrogen are the parts shaded green, and oxygen are actually the parts that you see shaded blue. So this is NGC 2244. Now, the next photograph is February 20th, and its name is Perseverance, How to Land on Mars. Now, this is one of the things that was mentioned earlier in this session. A lot of the photographs here are on aerospace and on space travel. And one of these right here is one of those photographs. This is a picture of the Perseverance rover. Now, if we look at the image credit, it says NASA JPL Mars 2020. That's because it's part of the Mars 2020 mission, and it was by NASA. This photograph, the engineers behind it work at JPL, the Jet Propulsion Laboratory, which is under NASA. So let's go to that photograph. Now, first, I want to talk about what is going on here. What is going on is that what you see here, this is the Martian surface. And you can see a lot of wind right here. This is actually wind on the surface. And then you've got the Perseverance rover, which is being carried by the descent stage. The descent stage was covered in the first photograph, and the descent stage acts as a little jetpack. You see, once Perseverance, the rover, enters the atmosphere, and after its parachute comes off, the heat shield is off, NASA uses a jetpack, an actual jetpack which has 8 thrusters to hover this rover just about 20 meters in the air, and then use these cables right here. These cables carry it down in what's called the sky crane maneuver. Now, one of the things here that is not exactly a cable is this one. This is not a cable. This is the umbilical cord. At least it's not in a cable whose purpose is mainly to carry it. The umbilical cord transfers information between Perseverance and the descent stage. Now, when it comes to something like this, they have to make sure that everything works very well, because what you're looking at right here, Perseverance, this entire project of Mars 2020, its building time took about 11 years from the part of thinking about it. Curiosity, which was the rover right before this, only took 7 years. And Burj Khalifa, for example, the tallest building in the world, took 6 years. Now, in terms of money, this rover its total cost was about $2.4 billion. The rover before this, Curiosity, took only about 2.5 billion, but that was because Perseverance is able to take some parts from Curiosity. They did not need to rebuild the whole thing. Now, Perseverance, it's also the first rover to use what is called terrain relative navigation. Terrain relative navigation is a software used where the rover, which has cameras on its bottom, as it enters the atmosphere, after it has gone through the entry and it's finding a place to land, it uses those cameras, takes pictures, and compares it with an onboard map. And it uses that to find the perfect place to land and touch down. At the same time, Perseverance is also the first rover to have the names of people all around the world. NASA started something where you can actually sign up, you fill in your name, and you get a boarding pass. Now, this boarding pass will have your name, has a picture of Perseverance, and the purpose of that photograph, of that boarding pass, it's sort of a certificate, because all those who signed up have their names on 3 silicon chips that are on a plaque on Perseverance itself. So, so yes, you've got about 10, it's close to 11 million names that are on Perseverance. Now, there are a few things that we can see from here of Perseverance itself. For example, we can see these wheels. The wheels have been deployed. Then you've got the super cam, which is sort of the head camera, the main circular camera that you see on its head. You also have parts of the drill that can be seen here. And one thing that I want for all of you to remember is this piece right here. These are called has cams, and we'll be talking about has cams in the next photograph. So moving on to the next photograph.
Wait a minute,
yes.
Allow me to add on. Mm-hmm. So we know that the gravity of Mars is only 30% that of the planet Earth. So on the planet Earth, the rover presence weighs 1 ton. Therefore, right now, it's hanging on the surface of Mars. Its weight is only 380 kilograms only, the rover. All right? Yeah.
Yes, that is true. This entire Perseverance rover has the weight of a car and is actually car size to a certain degree. The dimensions of the rover, it's actually 2.9 meters in length, 2.2 meters in its height, and 2.7 meters in its diameter, or in its width. Now, we'll talk more about Perseverance in the next photograph, where we actually cover the HazCam. So let's move on to the next photograph. So next photograph here is 2021, February 19, Mars Perseverance Sol 0. Now, as Dr. Chong mentioned previously, Perseverance is now on Sol 8. This photograph was taken on Sol 0. It was taken when it touched down. It is actually the first photograph to be taken by Perseverance. Now, when it comes to data transfer, Perseverance itself can send confirmations of touchdown. It can send information that the cables have been released and things of that sort. But when it comes to photographs, because photographs, they contain a lot of data. They are not just, they are not things such as touchdown confirmed. They are more than that. So what they have to do is that Perseverance actually sends this to an orbiter called the Mars Reconnaissance Orbiter, or MRO. So the MRO, the Mars Reconnaissance Orbiter, would then take that image and it would send it back to Earth. That's what this image here is. Now, as I mentioned just now, there was that HazCam. These HazCams are placed on the front and the back of all of the most recent, of all of the last 4 rovers to touch down on Mars. There have been a total of 5 rovers that successfully landed on Mars. The first was Sojourner in the 1970s. Then there was Spirit and Opportunity, the twin rovers, in 2004. Then closer to 2012, 2013 was the Curiosity. So around 2011, 2012 was Curiosity. And then most recently, Perseverance in 2020. Landed, of course, in 2021. Now, you can actually see the shadow of Perseverance here. So this is Perseverance itself. Now, the reason this looks warped, it's not because when Perseverance is standing there, or if you were to stand there, you would actually see it warped. No, Mars is not that small. This is because they used a fisheye lens. So in certain times when NASA wants to release more photographs, they do process it sometimes so that you don't see that fisheye curve. Now, to talk more about perseverance, its purpose is to search for life on Mars, is to see whether there is any ancient microbial life on the planet of Mars. Now, at the same time, it also has certain things to help future human missions. One of those things is something called MEDA. Now, MEDA stands for the Mars Environment Dynamics Analyzer. And what it does is basically measure the weather and try to predict the weather. Because weather is not something you want to mess around with on Mars. Weather will play a very important role in later human missions, so we have to make sure that we get those accurate. At the same time, there is another device called MOXIE. Now, this is a very famous device that was placed on Perseverance, and it stands for the Mars Oxygen ISRU equipment. Now, ISRU, it stands for In Situ Resource Utilization, which is basically to use the resources that you have in that area for a certain purpose. Now, in this case, the resource that they're using is carbon dioxide. Carbon dioxide fills up about 90+% of the Martian air. That's why we can't breathe there. But what MOXIE is going to try to do is basically to turn that carbon dioxide into oxygen, similar to what a tree does. It's basically turning this carbon dioxide into oxygen. And that oxygen can be used for many different purposes. Something that not many people actually realize is that oxygen and water, actually, not only oxygen, but in this case more specifically oxygen, it has a few purposes. For one, yes, it's something that we can breathe. Now, at the same time, when it's with hydrogen, it's something that you can drink, H2O, water. But at the same time, it's used in rocket fuel. You have your fuel and you have your oxidizer. That is the oxygen. So having oxygen on a planet such as Mars, which doesn't have that strong of a gravity, will be very useful in future human missions. Now, what else is there to say about Perseverance? Well, it's carrying along with it a partner, a technological demonstration called Ingenuity. Now, Ingenuity is a technological demonstration of the first powered air flight on Mars. Not the first air flight, but the first powered air flight, because there were flights done by the Russians using in Vega 1 and Vega 2, where they tried out a balloon. So it's not exactly the first flight or air flight, but the first powered flight, because Ingenuity is a drone. It's a helicopter. And this helicopter, it's very light. It has 4 legs and two counter rotating propellers. Now, on a normal helicopter, you would have 2 propellers. You would have the topmost propeller, which connects to the body, and then you have a propeller right in the back. There's a propeller right here. Now, the reason is, if you only have this one propeller, with only one propeller, the helicopter itself will be spinning around. You need something to counteract that. And to do that, most helicopters use this second propeller. Now, what Ingenuity does is that it actually has the second propeller on top, right here. So one will be rotating clockwise, the other one will be rotating anti-clockwise. So that way it balances the helicopter itself. So Perseverance itself has been packed with a lot of other things. Now, as I said just now, its purpose is to search for life on Mars. So one of the things it has is a drill section. It's a robotic arm, and right at the end is a drill that will actually drill out a chalk piece of Martian soil, and it'll encapsulate it and keep it in its underbelly. So it actually has 2 robotic arms on it. It's got the one that you usually see, which is the one that moves out, that drills things. But at the same time, it's got one in the underside that would take whatever samples from the drill and slot it into different holes on the bottom for storage. Now, at specific points, Perseverance will be dropping these samples, and it is planned that future Mars missions, perhaps in 2031, will go there, pick up the samples, return them to Earth, and run tests that we just can't fit on a rover. Now, besides that, Perseverance, one thing that I didn't mention, Perseverance and Ingenuity, just like Curiosity, got their names from schoolgoers. So NASA held a nationwide competition where different students would have to send in a name for the rover or the helicopter and the reason why they want it to be named that. So the names that were chosen were Perseverance and Ingenuity. Now, to end this photograph, I'd like to mention that this single photograph, it was sort of the sole reason that millions of people stayed and watched the NASA and watched the landing happen in real time. You see, in Malaysia, because of the time zones and the time difference, the landing happened at about 4:55, 5 a.m. Malaysian time on the 19th of February. So at least 40,000 Malaysians, those that sent their names to be on the rover, stayed up and watched this happen, including us. And it was all really for this photograph, this one black and white photograph. Now, yes, one thing that I did not mention was the fact that it is black and white. And the reason it's black and white is for faster transmission and to have better resolution. Now, yes, I do say better resolution, but it might seem to be a little bit blurry. That is because there's still a protective cover on it to protect it during the re-entry. Now, I may not have mentioned it previously. I did mention the cost of Curiosity and Perseverance, but just as a comparison. As I said, Curiosity was about 2.5 billion, Perseverance was 2.4 billion. The Burj Khalifa, for example, the tallest building in the world, was about $1.5 billion. So these rovers that we sent to Mars were more expensive than that. And there is a purpose to it, because all missions that we send to Mars, they are really to better our position on Earth. A question often asked is why do we go to space when we've got so many problems on Earth? It's to help. It really is to help the problems on Earth, because when we innovate and we create new technology and we learn new things in space and beyond, in Mars and beyond, those things end up helping us back on Earth.